So we're starting chapter 10 today, and what chapter 10 is all about is counting techniques, okay? Ways of counting things. And we're starting with this first section with small counting things. In particular, we're going to be looking at systematic listing. So if you take a look at some examples as you hear, you're going to see very small groups of things that we're counting. As we move into section 10.2, the groups are going to get bigger, and this method doesn't work very well, okay? So we're going to consider a group of students: Abigail, Bailey, Nate, David, Elias, and Macy. And we're going to list the different ways that we can form the following types of groups. And I've chose names that were different on their first letters so that when we write them, we only have to write the first letter down and it's distinguishable. So that's what you're going to see me using, is just the first initial, okay? So we've got a president and a treasurer. That's the group that's going to be created. And it's got the condition that they're not the same sex. Okay, so we're going to have one boy, one girl. That's what we're going to have. So as we're taking a look at this, we first can pick just the first person. So let's first pick Abigail. And we'll list president as the first entry and treasurer as the second one. Does that make sense? Just because that's the order they're given to us in. So if Abigail is president and we can't have another girl as the treasurer, then who could be the treasurer with Abigail? Yeah, it could be Nate. So it could be Abigail and Nate. Or it could be Abigail and David. Or Abigail and Elias. So we have three options with Abigail as president. Okay, so that's fine. But Abigail may not actually be the president, right? Like, that doesn't have to work out that way. It may be somebody else. So instead of Abigail being president, maybe we'll just go down the list, Bailey as president. So if Bailey is president, who could be the treasurer with Bailey? Nate? David? Or Elias? You got it. But maybe Bailey's not president either. So we go down the list. Maybe Nate's the president, right? So it could be Nate. Now, if Nate's president, now we've got a boy that's president, we have to make sure that the people that we group with Nate is going to be a girl. So it could be Nate and Abigail, or it could be Nate and Bailey. But maybe Nate's not president. Could be David, right? Oh, I missed Macy, sorry. Nate and Macy was the last one, so sorry. We hadn't come across her name yet, so I forgot about her. All right, so Nate and Macy. We could have David and Abigail. David and Bailey. Or David and Macy. But maybe David is not president, and it's Elias. So it would be Elias and Abigail. Elias and Bailey, or Elias and Macy. And then our last grouping will have Macy as the president. So it could be Macy and Nate, or Macy and David, or Macy and Elias. So you're going to have some inside of my math lab where you're literally listing things out like this. You're just listing a whole bunch of things. You want to make sure you don't double count something. You want to make sure you're careful not to leave anything out. It might be listed in a multiple choice form, okay? But either way you do it, you need to be careful that you're not leaving somebody out or duplicating. And that's the kind of pitfalls that can happen with it, okay? So just for the record, how many are there here? There's 18 different options. We'll come back to that thought in a little while, but there are 18 different ways that we could group these two positions based on this condition. Okay, we're going to make the condition a little bit stronger, or at least the group a little bit bigger now. So same students, but we're creating president, secretary, and treasurer, and it gives us the condition. Instead of it just being different sexes like the last one, we've got the president and the treasurer are the girls. Okay, so now we have to be specific on where we're putting people. So our president, being a girl, could start with Abigail. And then the second entry could be anybody, but the last entry has a condition on it still. It has to be another girl. So let's pick another girl to group with Abigail. You can do Bailey, just because she's listed next. Okay, so I'm going to put her, because it says the president and the treasurer, that's the first entry and the last entry, so I'm going to put them sort of with space between. So it could be Abigail and Bailey, but then anybody else could go in between. Even Macy could, right? It doesn't say that there has to be a boy as a secretary. It only gave us the conditions on the two, the president and the treasurer. So we could have Abigail, Nate, Bailey, Abigail, David, Bailey, Abigail, Elias, Bailey, or Abigail, Macy, Bailey. Is that okay? Okay. But we have another option if Abigail's president to begin with. We haven't listed all of the Abigail president options. It could be that Abigail's president and Macy is the treasurer, right? So if I do this one, I'm going to have 4 options here as well. Just the same, I mean, most of them are the same in the middle, but there's going to be one that's going to change. So again, it could be Abigail, Nate, Abigail, actually I'll put it in order. Abigail Bailey would be the first one listed if I go from left to right in my list. Abigail Bailey, Abigail Nate, Abigail David, Abigail Elias. At this point, we are not listing Abigail as president anymore. She can still be treasurer. We'll have some options with that in a little bit. But this is all the options that have Abigail as president. Okay? So how many options are there? There's 8 with Abigail as president. So how many do you think there will be with Macy as president? 8. And Bailey? 8. So we're going to end up with 8 times 3 or 24 of these different options on this one. Okay, so this is what I have for Abigail. Let's move on to, let me move it and make it a little bit smaller because I'm going to run out of space if I don't. So let's move on to Bailey as president. So I could have Bailey and Abigail. So it's going to look very much like that first line, just switched, right, with the Bailey and Abigail spots. And then I can put each of the different other students in between. So Nate, David, Elias, and Macy. But I could also do Bailey with Macy. And I could do this the same students in between. So Nate, we'll do Abigail first because we're going in order from left to right. Abigail, Nate, David, and Elias. So whatever kind of order it is that you're picking, I'm picking to go from left to right to make sure I capture everybody. Just stick with the same process the whole time so you don't miss or duplicate, okay? So I'm going from left to right. So this one was Bailey. And then I'm going to have Macy. Okay, so I can do Macy and Abigail, right? From looking from left to right, that's the first option, Macy, Abigail on all of those. That was a funny A. Let's try that again. And then left to right, I would have Bailey, Nate, David, Elias. Or maybe I don't have Macy, Abigail, I have Macy, Bailey. And then in between, I would have Abigail, Nate, David, and Elias. Okay, so as predicted, we have 8 times 3 or 24 of these. And again, just jot it down because we're going to come back and take a look at this. I think it's in 10-2. Okay, everybody good? Okay, the next one's a little bit different. The next one says I want a committee of 2 people. How is this different than some of the other ones? There's a couple of ways it's different. It doesn't have any requirements. Can you give me a specific requirement that you see missing, Julia? Okay, so there's no indication of them being boys or girls, right? Okay, so that's one thing that makes it different. There's something else that makes it different too.
This is committee instead of the specific titles.
Yeah, it's got a committee instead of specific titles. So if you think back to, let's say, we'll just go to the first example because it had 2 in it. Over here, there were 2 different ways of writing AN. There was AN and there was NA, right? And they were different because the president and the treasurer had different roles. But what happens in a committee? They're no longer different. It's the same assignment, right? Same title. So when I'm doing this next one, I won't duplicate and just switch the orders around. That won't happen any longer because I have a committee. Does that make sense? Okay, so we're looking at a committee now, and we'll just start with the first person, which is Abigail. And we'll list her with every other person because there isn't any condition on the sex of the other person. So we have Abigail Bailey, Abigail Nate, Abigail David, Abigail Elias, and Abigail, Macy. And what happens now is that I never list Abigail again, right? I already listed her with every other person. So when I move to the next person, which is Nate, I've eliminated the need to rewrite Abigail's name. I already wrote her with Nate once, so I don't write it again. So now Nate gets grouped with everybody after Nate. So it would be, Bailey's what I meant to do, going in order. Bailey gets grouped with everyone after Bailey. So it would be Bailey and Nate, and then Bailey and David, Bailey and Elias, and then Bailey and Macy. Once again, I've listed every combination now that has Bailey in it. No more Bailey involved. So now I'm going to move on to Nate. That's what I was trying to do before, sorry. Nate and David, Nate and Elias, and Nate and Macy. Okay, Nate's done. Who's left? David with Elias, David with Macy, and I have exactly one more grouping. It would be Elias Macy. Okay? And I've kind of written it this way so you can see how it gets shorter. The list gets shorter every time. That's the expectation because I've already listed all of Abigail's, or I've listed all of Nate's, or I've listed all of whoever we're talking about. Okay, so how many of them are there again? We're just going to jot it down for a moment. How many are here? 15. Okay, again, we'll come back to this. I don't think we'll come back to this actually today. It'll be another day, but we'll come back to this. All right, let's take a look then at another example. All right, so the last example, or the second example here, really like distinctly different, involves all of our last questions. So it talks about rolling six-sided die. Okay, so you've seen a dice before. You've played with them in games, I imagine. They're all equally likely sides to roll up, and they have dots on them, right? They have dots anywhere from 1 dot to 6 dots on a side of the dice, and there's 6 sides of the dice, okay? So what we're going to do is we're going to actually create a summation table for our dice, and it looks like this. So you do a column and a row like this, and you're going to list across the top row and down the right column all of the numbers 1 through 6. So all the whole numbers. So you have 1, 2, 3, 4, 5, and 6. And the same thing on the left-hand side. Okay, and what's going to go on the inside of our table is the summation. So literally a row and a column, let's say I'm just going to pick a random one, let's say this 4 and this 5. If I look at this row and this column, what I'm saying is I've rolled a 4 and I've rolled a 5, and in that spot where they cross, I'm going to write what their sum is, which would be the sum of 9, okay? So we're going to do this for the entire table. We can actually do this really strategically and go straight across, and every time it just goes up by 1, so the table becomes very quick and easy to do. So if I do 1 plus 1, I get 2, and 1 plus 2, I get 3, and 1 plus 3, I get 4, and then 5 and 6. Make sense? Every row works like that. It just starts with one number bigger, right? So I start with 2 plus 1, so that's 3, then I move on to 4, 5, 6, and 7. Sorry, they're not lining up very well. Let me try that again. Or I just didn't finish it. That's what it is. 7 and 8. There we go. Too much zooming in and zooming out on my screen. So sorry. Okay, what about row 3? Start with 4, and we increase, right? 4, 5, 6, 7, 8, and 9. So 4 starts with 5. 5, 6, 7, 8, 9, and 10. And then 6, 7, 8, 9, 10, and 11. And then 7, 8, and 9, 10, 11, and 12. Okay, does that make sense? Okay. This is actually a really nice table for the kinds of questions that are going to follow. So I am not saying that when you get to homework in section 10.1, the only thing that's going to be in the homework is questions that are mimic, people in committees and whatever, and rolling dice. But what I am saying is the problems that you see that are not like that have the ability to create another kind of a form like this to be able to answer the questions. Okay? So we're doing a style of question that you will have other styles of questions of potentially in section 10.1. So if you take a look at the questions that follow, we're going to be flipping back and forth between page 2, it's on my page 2 anyway, and the table that you created. Is all of yours on page 2? Oh, it is. Wonderful. That's even better. So that's good. Okay. So it's asking us how many ways we can actually get the following sums. So the following sums are 4, 11, odd, between some numbers and multiples. So 4. So you're going to look back at your table and you're going to find how many 4s are in your table? 3. And the answer is 3. That's it. There's 3 ways to get a 4. Now, if you didn't have created this table, that was bad grammar, but if you hadn't created this table, what would you do? Well, you'd have to think strategically about your dice, and that's okay. There's nothing wrong with that. You can think, oh, I could get a 1 and a 3. I could get a 3 and a 1, or I could get a 2 and a 2. Oh, look, there's 3 of them. And so this is not a very big problem to actually accomplish that particular one, the number 4. All right, what about 11? How many 11s are there in your table?
2.
There are 2. And again, it's not too bad to do this one just off the cuff without the table. How could you get an 11? Well, you get a 5 and a 6 or a 6 and a 5. Nothing else works because the dice don't get that big, right? For example, like you can get the number 11 by taking like 10 and 1, but there's no dice that has a 10 on it because we're working with standard 6-sided dice, right? So you can't just list all ways of getting the number 11. They have to work on dice, all right? So this is only 2. Odds a little harder. If you just wanted to do odds and you didn't have the table, this would be trickier to do. But with the table, it's actually very nice. So go through and find all the odds and count them up. Some of you are grinning at me like you already did it. Yeah? What'd you get? 18. So let's assume for the moment that you hadn't actually counted them. Do you have any other way of thinking about how you could get the number 18 without counting 18 of these guys? How many numbers total are in the table? Kyle?
36.
There are 36 numbers in the table, right? 36. 36 sounds a lot like twice the number 18, right? In your table, half of them are even and half of them are odd. That's what's going on in this table. So it's something to be aware of in how that this has been created as well. So there's 18. All right, between 6 and 15. Now, that sounds a little funny, or at least it should. Why does that or should that sound funny? Table didn't go that high, right? So even though it says between 6 and 15, we're not really counting things that go all the way up to 15. The highest we're going to count to is the 12, right? So you're legit going to be looking for 6 to 12 in the table. So count everything from 6 to 12. How many did you get? 26. Is that what you have? I don't have 26 written down, and I didn't actually count it right now. 21 is what I had, so... Oh, I know why. I'm sorry. This is my fault. I did not clarify this very well, and I definitely wrote the thing wrong. The word between, that's the word we want to look at. Between means that it has to literally be between them, so we would start at 7. That's my fault. I apologize. So keep in mind what we actually mean by sort of the grammatical structure of some of our words. Sometimes it might actually have the word between. It might also say something like less than or greater than or those kinds of things. We should have started at 7. And so there are 21 of them. Okay, so I'm going to make a mess of my table now. I was avoiding this till now. Multiples of 3. What does multiples of 3 mean? What are your multiples of 3? 3, 6, 9. Okay, good. I just asked the question in a way that was confusing, so sorry. All right, so 3, 6, 9, and 12. We need to find all the 3, 6, 9s, and 12s, right? So here's my 3s. Let me make that a bit bigger. Here's my 6s. Here's my 9s. And there's my 12. So how many of them did I highlight? 12. Did you get 12? Excellent. So there are 12. Wow, that was not good. 12 multiples of 3. All right, any question from 10.1 that you can think of at the moment? Kyle?
For a question, if there's multiples of, then you just divide the total by 100.
Divide the total what?
Total, like,
As long as it divides evenly, that works nicely. But let's say it said multiples of 5. 36 would not divide by 5 evenly, and then you'd have kind of a condition that you have to make a decision about. So does that make sense? Yeah. So because this one divided nicely by 3, right, there's 36 outcomes, you divide by 3, you get 12. That worked, but it doesn't always work very nicely.